Hi everyone, my name is Philippe Stemberger. I am a solution engineer here at Snyk, and in this session I'm going to walk you through how to design a security workflow from desktop to production. Because this session is quite short, I will focus on the three main elements of your software development lifecycle, and we will start by looking at how we can leverage Snyk into your local environment. How can we help your developer make more secure decisions from the very beginning? Then we will look into how do we integrate into your repository, into your source control management, preventing new vulnerabilities from being added. And we will then have a look into your CI/CD pipeline and see how we can embed Snyk into those for assuring that anything going to production has been vetted by your security team. Then, at the end, we will have a look at the reporting and how we can provide visibility to the overall business. But before moving into the platform itself, I think it is important to have a look at what exactly do we need to secure when we think about a security workflow from desktop to production. Indeed, historically, a developer was mainly responsible for building an application, leveraging some open source where applicable. However, nowadays, that range has expanded massively, and now the developer is not only responsible for building an application, they are also responsible for building the container that will host the application, as well as defining the behavior of that container when it gets deployed to the production. So we can really say here that the appearance of cloud has really shifted infrastructure into the code. So this is really the three things we need to keep in mind when we want to secure our applications. We need to think of what are the open source dependencies we are using, what are the containers that we are using, as well as is my infrastructure as code configuration as secure as it can be. The rest of this presentation will be mainly focused on what we do around open source dependencies for efficiency and time savings, but towards the end, I will rewind everything and tell you exactly how we can adapt these for containers and infrastructure as code. So let's jump straight away into my terminal. So in my terminal, the first thing I can do now is run a Snyk test command. This will extract my dependency, build a complete dependency tree including my transitive and their transitive, sending to Snyk, and here we can see that the result we've got back are really targeted towards the developer, telling them what is the one action they can take to improve their security stand straight away. Here, for example, I can see that if I'm upgrading Express from 4.12 to 4.16, I will be addressing 6 vulnerability coming from my transitive dependencies. Here we're telling exactly what to do to improve our position. But Snyk is not just about what we can fix, we're also going to give that full visibility to the developer, including the vulnerability that we can't fix. For example, here with handlebars, I can see that this one is coming from Istanbul, NYC and TAP, and even though there are some fixed versions, there is no way for me to introduce this into the path, so I can't do anything. If using some other languages like Java or Python, you could use this information to do this, but my project here is done in Node.js, and unfortunately for me, this is the end of the story. Now that I'm talking about languages quickly, Snyk is supporting a wide range of languages, including Java, Python, .NET, Golang, and so forth. But enough of that, and let's look exactly at what's happening here. I can see that I've got some license violation as well. Snyk is flagging them, telling me what exactly I need to do. For example, contacting my legal team, but in your case, it might be as simple as a link to a wiki page, a Confluence page, or maybe a short description letting know your developer why they shouldn't be using this dependency. But now, let's change gears slightly and try to add a new dependency into my project. Here, for example, I can run npm install tinymce that will add a dependency. I will then be able to commit and push it to the repository. So let's jump ahead and look at what that would be into GitHub directly. Here, we can see that this is exactly what I said it would be. We've added a new dependency, tinymce, and what I would have here as a developer is an instant feedback from the Snyk platform letting me know that if I was to commit this into the code base, I would add license violation as well as new vulnerabilities. If I want to know more about this, absolutely no problem. I can click on detail, go straight into the Snyk platform, and from there I can dive into the report. So let's jump into this and look at what exactly are we going to be adding into the code base. Here I can see that I have 7 new vulnerabilities. They are coming from this commit to this commit. So we're just looking at what we're going to add. We're not looking at our legacy issues. And here we're telling the developer what is the problem, what is the fixed version, what can they do about it. Because I would have developed this in context, I can now go back and change it straight away, being extremely efficient. But this integration into the repository is not just about preventing new vulnerabilities from being added. it is also about finding and fixing existing vulnerabilities into your application. So let's have a look into this project, directly import it into the Snyk platform. Here we can see that we're looking at exactly the same project. It is coming from GitHub, and if I start scrolling down, I will be able to see exactly which vulnerabilities I have and where my attention is required. If I want to see all of my dependencies, I can do so, and I can start diving into my dependency more specifically. For example, we were talking about Express. Express has a dependency on serve static, itself having a dependency on send, and then we can finally find where fresh is being introduced. If I wanted to find it straight away, I could have searched for fresh directly, and this would highlight a situation which can be quite interesting. Here I've got it 3 times. If I'm telling a developer that they have a vulnerability in fresh, they'll tell me that it's not true. I'll have to tell them it's a transitive. They'll tell me, great, how do I fix it? I'll tell them, well, install fresh 052. They'll ask me how, and then I would be quite in a tight spot. However, Snyk is here to help me. If I move into the issue tab and look for that vulnerability in fresh directly, I will now have an issue card that tells me exactly what I need to know. My vulnerability is in fresh, it is coming from Express, the fixed version is 052, and how do I get this into my application is through the detail path and remediation section. Here I can see, for example, in the last path we looked at, that my remediation action would be to upgrade Express to 415. I can now go back and make that change, or maybe I can, if I'm from the AppSec team, decide to fix it directly, click on the Fix This Vulnerability button on the Snyk UI. When I click on this button, I will be taken into a page where I can select which vulnerability I want to fix. In my case, this one is already pre-selected, but maybe I want to fix something else, like here in npm-conf. Be careful that some vulnerabilities will potentially break the application, and this is highlighted by that little warning signal that lets me know that I am gonna change the major version with that change. Now that I have selected which vulnerabilities I want to address, I can proceed with the creation of my fix pull request and go directly into GitHub. Here, we will have a bit of back and forth with GitHub API, ended up creating that pull request into GitHub directly, which is where the developer is used to sit. Here, going back into their native environment, trying to be as frictionless as possible. Here, we can see that we've got exactly what we would have expected. We're telling the developer exactly what we're changing. We're telling them why we're changing it. We're telling them if there is a risk of that breaking change, so no information is being lost. And if I was to look into which file exactly have been changed, I would see that I'm doing no more, no less than what I've advertised, changing the version of Express, changing the version of npm-conf, exactly what we would have done manually. But here it is done into the native environment where they're already used to it. From here, it is now time to have a look into the pipeline. Let's look at an example into Azure pipeline. Here I can see that I've got my Goof project, exactly the same one I've been using from the very beginning. And if I dive into the detail here, I will be able to see that my last build was failing. If I dive into that build to understand why, I will be able to have a look into the Snyk report, understanding exactly which vulnerabilities I have into my application. Here, I don't need to go back into the Snyk UI, the same way that in GitHub I didn't need to go back to the Snyk UI to get all of my detail. The information that is relevant is always at disposition of the developer. Now from here, if we dive into the pipeline itself, we will be able to see that that failing step is the Snyk security scan, and if we look into the detail here, it looks a lot like the CLI. And this is because all of our CI/CD integration are powered by our CLI, allowing us to leverage all the flexibility of the tool that developers like to use into the CI/CD, giving them exactly the same test and validation locally as we do into the CI/CD. But now that we've looked at all of those pillars, let's rewind and look at how we can apply these for containers and infrastructure as code. Let's go back into my terminal. This time, I can run a snyk test -- docker command saying which Docker image I want to scan, where is my Docker file, and this really allows us to understand how is the container being built layer by layer. That allows us to understand where each vulnerability is being introduced all the way back to the base image. If your base image is quite vulnerable, you will have a lot of vulnerability you will have to fix even before doing anything. If that's the case, Snyk will be able to help you by telling you exactly which image you could use instead, with either a minor or a major upgrade, or maybe some alternative images. As we can see here, Snyk is telling us exactly everything I've just mentioned. What is our base image, those minor and major upgrade we can do, reducing a number of vulnerability from 600 to around 500 and something, or maybe some alternative. This is not a rip and replace, but that's your best candidate in terms of what better image to start from than the one we're currently using. To fix these vulnerabilities, I'm simply going to scroll up, look at the description that I have, and understand that for each vulnerabilities, where do they come from, which instruction introduced them, and what is the fixed version that I can use instead. If I want to look at another example of Docker, I can have a look into the registry. If I look into a registry, I will have exactly the same thing. Here I'm coming from Docker Hub, but I can see the same base image, the same recommendation, and the same issue description in the count below as we add for the open source dependencies. It is really the same thing across the platform to make sure that once you understand one area of the product, you can really navigate into the other quite easily. So what about our infrastructure as code? Here as well, we will be able to scan that directly from the repository. If I look at an example here, coming directly from GitHub, I will be able to see exactly in the file at the exact location what kind of problem I have. Here I'm using resources by default, but default doesn't mean secure, and I can see exactly why not limiting my CPU, not limiting my memory could be a problem. In terms of capabilities, if I don't remove any, that can be a problem. If I'm adding some, that can be a problem as well. Here as well, we're giving all the instruction that you need, all the context that is required to be able to address those vulnerabilities. Now, going back into my terminal one last time, I will be able to run exactly the same kind of validation. If I run a Snyk EIC test, linking that to the file I've just tested in my repository, I will have exactly the same feedback, understanding exactly how I can fix things, iterate on it very quickly locally, and as we can see that exit code here, that's how I would use it to break your builds in the CI/CD. If you remember, the two are linked. Now that we've seen everything we needed to in terms of open source dependencies, container, and infrastructure as code, it is time to have a look at the reporting. So let's jump into the platform and have a look at the reporting area. The first thing we have here is an overview of the situation. What is my number of issues over time and their distribution? What is the exposure window? Are they new? Are they old? What exactly is happening here? If I want to dive into more detail, I can go into the issue area. Here I will have a complete view of everything I need. I can export those as a CSV, I can use an API, but here I've got all the data I need to ask myself questions like, what is my top 10 project with fixable issues, so I can have a win today? What is my top 10 project with an issue regardless of fixability, so I know where to focus next? Or maybe even, what is my top project with no vulnerability or as little as possible to identify a champion? Another thing Snyk can do is providing you with bill of material. It is fairly easy for us to show you your fragmentation, different version you're using of the same dependency, if there is any vulnerabilities, what is the license behind them. And then we can flip this view around, showing you all of the license that you have in place, exactly how they've been introduced, from which project, and if you need to, you can start now the conversation with the different development team, making sure that those issues get addressed. Maybe there's nothing to do, it's just about ignoring them. That is also something we can do. There is a lot I haven't had the time to show you about the platform. This session was a bit intense, apologies for that, but let's have a summary of what we've discussed in this session. We started by looking locally, what can we do? How can we find and fix vulnerability into your local environment? From there, we've looked at how we can prevent vulnerabilities from being added into the code base with the integration into the repository. That then unlock how we can automatically fix vulnerabilities into your application with the fix PR directly from the Snyk platform. We then transition into your CI/CD, looking at how can we break a build, how can we create a security gate, making sure that everything going to production is as secure as we could. Here, as you can imagine, I focus on this area. There is way much more at play. There is things after the security gate as well. We can do some monitoring there and things more targeted. But the goal of the session today was really to focus on building that security workflow from desktop to production. I hope you've learned something. Thank you for your time and your attention. Develop fast, stay secure. Goodbye.